So here are your notes for lesson 4-2. Please keep your 4-1 and any assignments you have until I get back, and I'll take questions before I actually collect them. So we have a proof to start off the day. Remember, as of right now, we know to prove two triangles congruent, we need all sides and all angles. So we need 6 things. So looking at what we have here, we are given that angle A and angle D are congruent, angle AE and CD are congruent, EB, BC, BA, BC. So right now we have F, an F, an F, and an A. And we're trying to prove that AEB is congruent to DCB. So we're almost there. So let's get all our given stuff in. And I'm just copying it exactly the way it is in the given. So please let the teacher know if it needs to be paused so that you guys have time to fill things out. So just give them a nice friendly, can you slow it down, and we can just hit pause and you have time to write everything. So here's our given. So again, there's an angle, a side, and a side, and right now we need all 3 angles and all 3 sides. So looking at our picture, where can we get our missing information? So it looks like we need 2 more angles. So right away I noticed this relationship right here, and you guys should know what that one is. Yep, it is vertical angles. So angle ABE is congruent to angle CBD because of the vertical angle theorem. Then I need this third pair of angles. Oh, and I think I gave you a hint. How do we know that if we have 2 pairs of angles congruent, the third pair is congruent? Yep, the third angle theorem. So angle E is congruent to angle C because of the third angle theorem. And now I have all 3 angles and all 3 sides, so then I can say the triangles are congruent. Because all sides and angles are congruent. So please hit pause if you need more time. It turns out that you can prove 2 triangles are congruent without having to show all corresponding parts congruent. So we have this thing called the SSS congruence postulate. If 3 sides of one triangle are congruent to 3 sides of a second, then the 2 triangles have to be congruent. So this cuts down from 6 things down to 3. So here is our second proof. So let's write down what's given. And I always like to number them. So our 2 pieces of given information are an S and an S. So we have 2 pairs of sides congruent, and now we need that third side. So if I split these 2 triangles apart, this is side BD, and this is side BD. So how do I know that BD is congruent to itself? It starts with an R. Reflexive. So BD is congruent to BD, the segment, because of the reflexive property. So now we have all 3 sides mentioned in our proof, so we are complete. So triangle BCD is congruent to triangle BFD. And our reasoning now is S, S, S. is all you have to write down. So once we get all three sides congruent to each other by the SSS theorem, those two triangles have to match. So now we know that corresponding angles are congruent also, F to C and then those little angles. The next vocab word you need to worry about is included. So angle A is included between segment BA, so this side right here, and this side right here. So it is in between them. BC is included between angle B and angle C, so it's in between. And that becomes important in the next two theorems that we have. So name the included angle between the pair of sides given. So we have MT and TR. The included angle would be angle T. And then we go with TQ, the side, and QR, the side. That would be angle Q. And then RT, so this side, and RQ, this side, the included angle would be angle R. So what is in the middle? Again, pause if you need more time. One more shortcut, the SAS. So we have to have an included angle in between those two sides. So if two sides and the included angle of one triangle are congruent to two sides and the included angle of a second, then the two triangles are congruent. Order matters. You need to make sure that it goes SAS. You can't have an extra side or angle in between. So here is a proof. So let's get the given information going. So we are given these markings. So I see step 1, AE is congruent to ED because it is given. And step 2, BE is congruent to EC also because that is given. So right now we have a side and a side. So our options are to prove SSS or SAS, or we can prove all 6, but I think we want to stick to one of our shortcuts. So is there any way we can get this side and this side congruent? No. So we're going to work on these angles. So how can I say angle 1 is congruent to angle 2? We have a theorem for it. Vertical angle theorem. So I'm just going to mark my picture. So now, step 4, triangle AEB is congruent to triangle DEC because of SAS. And it was really important to have that angle included between those two sides, otherwise it wouldn't have worked. The last thing we're going to do today is justify. Are the two triangles congruent? If so, list the postulate that justifies why. So our options are SSS and SAS with that included angle. So number 3, the top and the bottom triangle, are they congruent? I'm going to say yes because of SAS. Double check that that angle is between those two sides, and it is. Number 4, are these two angles vertical? No. Do I see reflexive for any side length? No. So these two triangles will not be congruent. And we are not going to explain why they are not. We just kind of did. Number 5, we're looking for a third piece. So the included angle would be P and S, and those are not going to work. So the missing piece is by reflexive, so yes by SSS. This concludes the lesson. Make sure you save any homework for me for tomorrow.